Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals. And here we are given this problem where we have to make use of properties of definite integrals, right? So let us first read out this problem. And here we have the problem: consider a function f of x such that f of x plus f of 2 pi minus x is equal to pi square over 4 for all values of x belonging to the set of real numbers. Then we have to find out the value of this integral, that is 0 to 2 pi f of x sine square x dx. So now let us first take this integral as I. So here we'll assume I is equal to the integral 0 to 2 pi f of x sine square x and dx. Now let us make use of this property of definite integral, that is 0 to a, and we have say f of t dt is equal to 0 to a f of a minus t dt. So this is an important property of definite integrals which can be utilized in this integral, right? Because this property is a particular case of this one, that is a to b f of t dt is equal to a to b f of a plus b minus t and dt, right? So let us call this integral as integral number 1, and let us apply this property to this one. So here the value of a is 2 pi, right? And for f of t, here we have this function, that is f of x sine square x. So let us replace all these x by 2 pi minus x due to this property, right? So we have now I is equal to 0 to 2 pi, then we have f of 2 pi minus x, and then we have sine square, and here we have 2 pi minus x dx, right? Okay, now let us take some help from trigonometry. Now see, here we have sine 2 pi minus x, and from trigonometry we know that sine 2 pi minus x is given by minus sine x, so that the square of 2 sine square 2 pi minus x is given by minus sine x square, and that is positive sine square x. So here we can replace this term by sine square x. So we have now I is equal to 0 to 2 pi and f of 2 pi minus x, and here we have sine square x dx. So let us call this integral as integral 2. So now let us add 1 and 2. So adding 1 and 2 will get I plus I in the left hand side, and in the right hand side we have 0 to 2 pi f of x sine square x dx plus integral 0 to 2 pi, and here we have f of 2 pi minus x, and here we have sine square x dx. So I plus I is 2i, and here we can see that in both the integrals the limits of integration are same, right? And here we have sine square x, and here we have sine square x. So we can now write 0 to 2 pi, and we can take f of x plus f of 2 pi minus x, and then here we can take sine square x common, so we have sine square x dx. Now see, we are given in the problem that is f of x plus f of 2 pi minus x is equal to pi square over 4. So let us replace this quantity by pi square over 4. So we have 2i 0 to 2 pi, and here we have pi square over 4 and sine square x dx, right? So let us rearrange the terms. So here we have pi square, and here we have 4 times 2, that is 8, and then we have 0 to 2 pi and sine square x and dx. So now we have to evaluate this integral, right? So in order to evaluate this integral, let us make use of trigonometry, and we know that sine square x is given by 1 minus cos 2x over 2, right? So from the double angle formula for cosine function, we have this result. So we have pi square over 8, 0 to 2 pi, and here we have 1 minus cos 2x over 2, and here we have dx. So this is pi square. Taking this 2 outside the integral, we have 16, and 0 to 2 pi and 1 minus cos 2x and dx. So now we can easily integrate 1 minus cos 2x. So we have here pi square over 16, and the integral dx is x. So here we have x, and the integral of cos 2x is sine 2x divided by 2, and the limits are from 0 to 2 pi. So now let us substitute the limits, and we'll take the difference. So when x is 2 pi, we have 2 pi minus sine 4 pi. Here we take x is equal to 2 pi, and here we have 2, and then we have 0 minus sine 0 over 2. So this is pi square over 16. This is 2 pi, sine 4 pi is 0, and here we have 0 minus 0, because sine 0 is 0, and sine 4 pi is also equal to 0, because we know sine n pi is equal to 0 for n any integer, right? Okay, so here we have pi square over 16, and here we are left with only 2 pi, right? So this is pi square times pi is pi cube, and here we have 8, right? So the value of this integral, that is I, is equal to pi cube over 8, which can also be written as pi over 2 whole cube. So viewers, this is how, by the application of the properties of definite integrals and some concepts from trigonometry, we can easily solve these kind of problems.